On August 17, 1925, an event occurred that forever changed the fate of one unusual aircraft. That day, several bombers from the 11th Squadron were preparing for a group takeoff from the military base in Neverhaven, Wiltshire. Also present at the airfield was Mr. Robert Bruce, director of the Westland Aircraft Company, who had arrived in an experimental passenger aircraft called the Limousine. This plane was parked in what was considered the safe part of the airfield, but when the military bombers began to take off, tragedy struck. One of the pilots, Lieutenant Madison, failed to calculate the trajectory properly and crashed directly into the rear of the passenger limousine. Both planes were completely destroyed, although fortunately the pilot and his assistant were unharmed. As it later turned out, this accident became an unexpected gift for the team of enthusiast designers from Westland. The fact was, they needed an engine for a special project, a plane they were developing in their free time and building in a workshop at the company's expense in Yeovil, Somerset. The whole story had begun back in 1924, when a group of engineers decided to create a high-speed racing aircraft. Among the developers was Tony Fletcher, who had come from Martenside. The strength calculations were carried out by engineer Henry Edward Medham. The company's chief test pilot, Major Lawrence Openshaw, supported them with advice and encouragement. The chief designer, Arthur Davenport, who had always favored monoplanes, also unofficially approved the project. The design was simple and inexpensive. The team hoped Bruce would agree to build it. The aircraft had a wooden structure. It was a monoplane with a wing mounted above the fuselage, supported by special struts. The wing was built using a box-type main spar and ribs of a special lattice construction. The fuselage consisted of a cylindrical central section to which the engine and bracing were attached, and a streamlined rear section of circular shape with a frame and 4 longerons. When in January 1925 Bruce was shown a sketch of the project, he studied it carefully and suggested several changes. In particular, he replaced the central supporting struts with a pair of cantilever struts along the center line. Bill Widgery, responsible for the company's wind tunnel, reported that he had conducted model tests and that over the following months more than 60 such tests were carried out, including studies of the effect of a working propeller. As a result of this work, the wing profile was changed from one type to another, more efficient one. After Openshaw proposed using the powerful 275 horsepower Rolls-Royce Falcon engine from the wrecked limousine, additional tests were carried out during construction of the aircraft to determine the best nose shape. In September, while work on the plane was in full swing, major structural changes were introduced. During a visit to the Experimental Center for Aviation and Air Armament at Martlesham Heath, Suffolk, Openshaw was impressed by the metal fuselage frame of the single-seat Hawker Heron fighter. This frame used steel and aluminum tubes whose ends were flattened into a rectangular cross-section and joined by reinforcing plates and bolts. Quickly realizing the advantages of such a design, Bruce decided to cut off the nose of the monoplane as far back as the cockpit and replace it with a structure of aluminum tubes of square cross-section. Instead of joining the tube ends directly together, a gap of 1/8 of an inch was left, and all loads were carried by reinforcing plates attached to the tubes with rivets instead of bolts. Bruce saw this as a simple way to transition from wood to metal construction, and the head of the experimental shop, Fred Reimel, prepared a new fuselage nose in a couple of weeks. The nose of the fuselage included the engine mounting and also carried 2 cruciform metal axial struts. This part of the fuselage was covered with metal skin, while the rest of the fuselage, as well as the wing and control surfaces, were covered with fabric. Ailerons with special balances occupied the wing's trailing edge over about 1/4 of its span. The tail unit consisted of a small triangular fin with a cutout for the balance of the broad rudder, which continued the rising line of the fin's leading edge, and a rectangular braced tailplane with broad elevators. The streamlined main landing gear struts were attached at the junction of the forward wing struts and the lower longerons and were fitted with medium-pressure oleo-pneumatic shock absorbers manufactured by Westland. The wheel axles were extended forward from the center line to the front of the engine frame. After preliminary engine runs, the new monoplane, without any markings, was readied for its first flight before a small audience of company employees on a bright sunny Sunday morning in November 1926. After a takeoff run of about 600 feet, Openshaw lifted the plane into the air and flew away to test its climb. 12 minutes later, he returned to perform high-speed passes, sharp climbs, and steep turns before landing in front of the delighted spectators. However, there was still work to be done. The ailerons proved too heavy and had poor responsiveness, the rudder was ineffective, and the elevators were overly sensitive. In addition, the aircraft showed a tendency to bounce on landing. Before the second flight, several weeks of work were required to correct the shortcomings. The rear parts of the wingtips were made rounded. Large ailerons with reinforced compensation were installed. The size of the elevators was reduced in a fairly simple way. A false trailing edge was added, and the originally elongated frame, which had not been covered with skin, was removed. Then elevators of reduced size were installed, and to increase the fin area, a large plywood overlay of simple design was added to its upper part. However, the flight tests of the Wizard, the name given to the new aircraft, suddenly stopped when an airlock cut off the engine immediately after pilot Openshaw took off in Yeovil. He managed to land the machine on a narrow strip between new houses north of the airfield. Yet this strip turned out to be too short, and at high speed the Wizard crashed into a fence and overturned. Openshaw received only minor injuries, but the aircraft was seriously damaged. Fortunately, Bruce was already impressed by the Wizard's characteristics and decided that the company would continue to finance the project. Moreover, there was now the opportunity to make significant changes and improvements to the design. The most important of these was the creation of a completely new all-metal fuselage. The power plant was to be a 12-cylinder V-type liquid-cooled Rolls-Royce Falcon engine of 490 horsepower from an early experimental series. The redesigned aircraft was ready by November 1927, the month when Westland Company test pilot Captain Louis Paget made his first flight. It was at that time, during the factory tests, that the Ministry of Aviation became interested in the aircraft. According to the specification, which required a 2-machine-gun all-metal fighter to replace the Siskin and Gamecock in the squadrons of the Metropolis, the Wizard was equipped with sighting devices. Since up to that moment the Wizard, the designation assigned to the aircraft by the Ministry of Aviation, had been a private venture, in November 1927 it received a military serial number. The new fuselage consisted of 2 parts, the front and the rear sections. The front part resembled that of the first machine and was made of steel and duralumin tubes. The differences from the original version lay in its greater length so that the front section could include the cockpit. The metal skin was also extended. This time provision was made for the installation of 2 fixed 0.3-inch Vickers machine guns firing forward, as well as the option to carry 4 bombs weighing 20 pounds each. The placement of the Falcon engine was designed to ensure easy access to it and the possibility of rapid removal. Once the cowling panels were taken off, the engine mount was completely open for access. A reduction gear with a ratio of 0.631.1 was installed on the propeller shaft, allowing the use of a larger and therefore more efficient propeller with a spinner. The engine mount was of welded construction in the form of a single unit, and with the use of suitable cushioning materials, it was possible to install different engines. The engine had exhaust pipe manifolds. Starting was carried out with a Huck starter connected to the propeller hub. By means of a crank handle, it was inserted from the left side and engaged directly with the engine. Hand starting with a starting magneto was also used. Immediately behind the firewall was a tank containing 5 gallons of oil connected to a Westland oil cooler. The ribbed surface of the radiator was curved in accordance with the profile of the lower part of the fuselage. Between it and the pilot's seat, there was a retractable radiator controlled from the cockpit by a handwheel. In the fully retracted position, it projected from the fuselage by only 2 inches and also served as a very effective cockpit heater. The fuselage closely enclosed the pilot's head, providing him with visibility downward, forward, and rearward on both sides. The machine guns were mounted on adjustable brackets, and inside the fuselage they had their own channels and stops. The guns were located at the level of the pilot's arms and lay against his seat, allowing him to observe the armament and reach it effortlessly. On the ground, the machine guns could be swung outward to facilitate adjustment and barrel replacement. The barrels projected from long channels and had cutouts on each side in the lower front part of the fuselage. The pilot's seat height was adjustable on the ground, and the rudder pedals, the only wooden parts in the fuselage, had 2 positions. Near the seat were Sutton harnesses or other types of safety belts in use. The control stick was connected to the trigger levers of the machine guns. Under the pilot's feet was an ammunition box with 600 rounds for each of the guns. The machine guns were synchronized with a special mechanism. The aircraft was also fitted with a ring sight with a spherical bead and an Aldous sight. The engine control and radiator regulator were conveniently placed near the pilot's left hand, while with his right hand he operated a lever that, through a special mechanism, was used to trim the tailplane. Also on the right were the engine starting handle and the bomb release lever, which could drop the bombs either individually or all at once. In front of the pilot was an instrument panel with an altimeter, airspeed indicator, cross level, clock, oil pressure gauge, tachometer, fuel cock and priming pump, as well as oil and water thermometers. Below the panel were the controls for the oxygen equipment, gauges, and the cylinder. In the center of the upper part of the instrument panel, a compass was installed. The fire extinguisher was placed directly in front of the pilot's seat to his left. The fuel level gauges were attached to the upper crossbeams of the fuselage, one on each side. In the fuselage, in the fairing immediately behind the cockpit, there was a compartment for a removable packing box for radio equipment. The radio receiver controls were within the pilot's reach. The new rear fuselage section had structural elements made of duralumin tubes of square and circular cross-section, the ends of which were fitted into special sockets with seals secured by single bolts. Fastened with connecting rods, the structure had a streamlined shape with metal frames and stringers. The skin of the rear fuselage was fabric-covered. At Westland, it was claimed that the monoplane layout with its rigid wing, free of independent struts and bracing wires, offered outstanding advantages in terms of maintenance. Although the prototype had wooden lifting surfaces and ailerons, it was intended that these would be made of metal in production aircraft. The two-spar parasol wing was built in the form of two panels hinged together along the center line. Thus, the wing had no center section. A pair of streamlined cabane struts rose from the top of the fuselage to connect with the wing panels. Pairs of streamlined struts from the lower fuselage spars were attached to the front and rear wing spars at about half span of each panel. Intermediate vertical auxiliary struts of streamlined form were positioned between the main struts and the wing spars. At these points, the main struts were also braced with connecting rods and cross-braced with wires. Since the front struts were made to length and the rear ones were fixed in the position most suitable for adjustment during pre-delivery trials, no further adjustment was required in service. The ailerons had shielded horn balances at their tips and tapered inwards towards the roots, ensuring maximum controllability with minimum effort. Described as very effective, they were actuated by an intermediate shaft, chain drive, and levers connected to the rear spar. In turn, the rear spar was linked to the ailerons by levers. To reduce drag, the whole system was enclosed within the wing. Easily removable 34-gallon fuel tanks, about 154 liters, were housed in the root sections of each wing panel. Fuel was normally pumped to the engine. If the pump failed, fuel could be gravity-fed at normal angles of attack. The radiator header tank was fitted in the leading edge at the wing center. The tail unit was made entirely of duralumin. The angle of incidence of the two-spar tailplane could be adjusted from +6 to -2 degrees, with the rear spar having a movement range of 3 inches. On each side, the stabilizer spars were connected to the lower fuselage spars by a pair of struts. The unbalanced elevators, of constant chord, were operated through push rods, levers, cables, and intermediate shafts. A small triangular fin had a cutout for the rudder horn balance. Although Westland drawings still showed a horn balance extending along the fin line, the aircraft carried a fin resembling the modified fin of the original machine. The main undercarriage struts remained unchanged. The duralumin tail skid was sprung with compression rubber blocks and fitted with a replaceable steel shoe. The skid was steerable, being linked to the rudder bar and fitted with a spring to absorb shocks. The rebuilt Wizard was not equipped with electrical wiring, and in some cases, dummy equipment was fitted to allow faster testing. Radio equipment was also not intended for the aircraft offered by the company to the Royal Air Force. With a remarkably fast climb to a speed of 190 miles per hour, Page found the Wizard to be a quick machine. However, lateral control was unsatisfactory, so some time was spent adjusting the aileron horn balances until light and effective control was achieved. On January 29, 1928, Page flew the Wizard for official performance trials. The upper fuselage was painted bright blue, with "The Wizard" written in elegant script on both sides. The notoriously uneven surface of Martlesham Heath Airfield proved a real test for the Wizard, which suffered serious damage over several months. At the end of February, the tail skid broke. In April, the telescopic strut of the tail skid broke while taxiing, and in mid-May, the most serious accident occurred. The undercarriage collapsed. While taxiing after a flight, the right-hand axle fittings failed. This critical part, made of solid steel, carried the oil-damped strut, half the axle, and the wire cross bracing. During the accident, the section to which the half axles and bracing wires were attached was completely torn away. Although the aircraft was moving slowly at the time, the damage was enormous. Not only did the undercarriage fail, but the propeller was broken, the right wingtip damaged, the supporting struts fractured, and the fuselage badly distorted. This brought about the premature end of testing of the first version of the Wizard, but on June 4, 1928, a mandatory incomplete interim report was submitted. It recorded that the aircraft flew at an all-up weight of 33.26 pounds, with the engine producing 552 horsepower at 2,250 revolutions per minute under normal conditions. Overall, the controls were good. Lateral control was rather heavy but effective throughout the speed range. Elevator control was usually light but became heavy in fast turns. At speeds near the stall, rudder control lost effectiveness. Taxiing required care, and the takeoff run was described as very long. The Wizard's maneuverability was considered inferior to that of biplanes, and the fighter was sluggish both in entering and leaving turns. Although the view for bombing was considered good, it was insufficient for air combat, low-level flight, and landing due to the long nose of the aircraft, the small distance between the fuselage and the center section of the wing, and the large struts of the center section. However, the report stated, "It is quite clear that the contractor's proposed modifications, combined with the installation of a new engine, will make it possible to significantly improve the forward view." The cockpit turned out to be well arranged and comfortable. With the engine running, it was warm, but during long gliding with the engine off, it became cold. It was deemed necessary to considerably enlarge the open part of the cockpit so that the pilot could quickly leave it in case of emergency. Performance tests were carried out at an altitude above 1,000 feet. The rate of climb at this altitude was 1945 feet per minute, decreasing to 550 feet per minute at 2,000 feet. The estimated maximum ceiling was 24,000 feet, with a practical ceiling of 23,250 feet. The maximum true airspeed at 10,000 feet was 188 miles per hour, and at 2,000 feet it was 162 miles per hour. Landing speed was 72 miles per hour, and the landing run without wind was about 310 yards. The Wizard was particularly good for equipment installation, and it was considered that it would not create any difficulties regarding maintenance in Royal Air Force squadrons. The results of the Wizard accident were undoubtedly disappointing, but in the report, Westland recommended repairing the damaged fighter without delay. The interest of the Air Ministry was sufficient to issue a contract, and the Wizard received a military serial number. The records state that the aircraft returned to the test station on June 27th, and on June 30th it appeared at the Royal Air Force Air Show as New Type 5. This identification number and the military registration number appeared on the sides of the rear fuselage. The journal, The Aeroplane, wrote, "From the public point of view, this was, of course, the highlight of the single-seat fighter program. No official data on its performance were reported, but reliable sources claim a speed exceeding 210 miles per hour. Judging by its speed against the wind and its exceptionally high rate of climb on takeoff, this is entirely believable." On July 3rd, the Wizard was returned to the factory. The fighter was to be rebuilt as a second version with a metal wing for participation in the competition, which required a single-seat interceptor fighter capable of catching up in the shortest possible time with an enemy bomber flying at 2,000 feet at a speed of 150 miles per hour. The fighter had to be able to reach this altitude in less than 12 minutes and have a speed at that altitude of not less than 200 miles per hour. The primary requirements were good combat visibility and maneuverability. The official tests were to provide comparative trials of biplanes and monoplanes with both low and high wing placement. The most notable feature of the new two-spar duralumin wing was that it now consisted of a center section and two outer panels. The center section was made small to reduce obstruction of the pilot's view and was supported by 4 tall struts. It had a chord of only 4 feet 334 inches, and the cutout in the trailing edge was much larger. The wing panels had a somewhat larger chord, 6 feet 6 inches, than the first version, 6 feet 5 inches, not reduced as some sources report, and inserts with mounted ailerons. The overall wingspan was increased from 39 feet 6 inches to 40 feet. Another major change was the installation of a supercharged Rolls-Royce engine for which mountings were prepared, with a slight increase in radiator area. Work on the second version of the Wizard continued during the first months of 1929. Even by the end of February, engineers were still making changes in the company's experimental shop. After the first flight and factory tests in September, the aircraft was sent to the testing center for a detailed examination of its flight characteristics. Experienced military test pilots quickly noticed a serious problem. The tail section of the aircraft vibrated heavily in flight. In addition, there was excessive wear on the rods connecting the elevators with the intermediate shafts. The company urgently installed larger diameter connections to eliminate the play caused by loosened fastenings. Then, the uneven surface of the Martlesham airfield again made itself felt. In early January 1930, the tail skid was destroyed during taxiing. The main tube of the shock absorber broke under tension. During repairs, Westland specialists installed a reinforced transition sleeve. An interim report of the testing center was issued in February 1930. It mistakenly claimed that the aircraft had not changed compared to the first version, except that instead of the vertical strut which previously joined the two wing panels at the plane of symmetry of the fuselage, a center section was now installed. Unfortunately, there was a general deterioration of controllability. It was stated that controllability and maneuverability were not very good for aircraft of this class, and quite modest from the point of view of air combat. The aircraft did not have quick responses to control actions, and although the stall occurred at low speed and during it the controls were very effective, the Wizard's too low speed on approach could lead to loss of height with a sharp impact on the ground. On the other hand, because of very shallow gliding angles, pilots tended to approach at too high a speed. With a slipping turn, the aircraft gained speed and it was difficult to lose altitude. After landing, it maintained its speed on the ground for a long time. These factors made the Wizard difficult during the approach and landing itself, especially on small airfields and enforced landings. The pilot's view was still obstructed by the long nose and the position of the wing relative to his seat, which prevented him from having a clear sense of what was happening ahead and above during the climb. Although takeoff was fairly easy, the tendency to veer to the right required a left rudder correction immediately after the engine throttle was open. Taxiing was generally simple, but due to the narrow undercarriage track, the aircraft was top-heavy and unstable if a strong wind blew during taxiing. The Wizard's cockpit was described as the most uncomfortable, with the pilot forced to sit stretched out, which during long flights led to cramps. The instruments were conveniently arranged, although the switches, fuel cocks, fire extinguishers, and machine guns were easy to handle and operate. The radiator control lever was set too far back and was difficult to use, as was the stabilizer incidence adjustment wheel. The lack of an adjustable seat was a serious omission, and the rudder pedals were too short and awkward. Stability tests showed that the Wizard was unstable in pitch and yaw and provided an unsteady gunnery platform. Spin trials were satisfactory, recovery was smooth. Since the elevators were disconnected, dive tests were considered pointless and were not carried out. The report concluded that due to various shortcomings, the Wizard did not fully meet the technical requirements. With an overall weight of 3,444 pounds at an altitude of 15,000 feet, the maximum speed achieved was 197 miles per hour, and at 2,000 feet it was 194 miles per hour, which was below the set requirements. At a speed of 150 miles per hour, it reached the interception height of 2,000 feet in 14 minutes 52 seconds, which was almost 3 minutes longer than the time specified. All this apparently marked the end of official interest in the Wizard, although the aircraft remained in existence for some time. At the end of April to early May, it was discovered that the front support and the left landing gear strut joint were damaged, and that the rivet holes in the diagonal element carrying the landing loads had been stretched by compressive forces. The Wizard was returned to Yeovil, where new brackets with corresponding modifications and joint reinforcements were installed, and some rivets were replaced with bolts. In March 1931, the Wizard was sent back to the test center, most likely for armament trials of the 15th Squadron. After another return to Yeovil, it was recorded that on November 12, 1931, the aircraft was once again sent to the test center, but no further reports seem to have been made. Reg Butler, who from July 1930 worked for 4 years as a fitter and aircraft mechanic at Martlesham, recalled that under Flight Lieutenant Scroggs and A.E. Paish, the Wizard spent most of its flying time in high-altitude equipment trials. He recalled that the engine with its short exhaust pipes produced a very distinctive crackle when the throttle was closed, and that when the Wizard descended from altitude, he could always locate it by that sound. Butler believed that the aircraft was eventually scrapped,